Hello, everyone. My name is Ma Jinpeng. I'm a developer from Binkai. I'm so glad to be here and share you with how do we test TiDB using Chaos Mesh with TiPocket. Thank you for joining me. TiPocket is a testing platform. It's a testing platform we develop based on Chaos Mesh for testing TiDB. Okay, let's start. This is today's agenda. I will first give you an introduction to TiDB and Chaos Mesh from our testing perspective. And then I will introduce the reason why we developed the TiPocket and share you with the overall architecture of it. Finally, I will show you how we use Argo to manage the cases we have written. Distributed system testing does matter. From this picture, you can see that many applications today are data intensive. They are usually built from many building blocks, include database, cache, for testing index, and MQ, etc. So reliability becomes one of the most important factors we have to consider. The reliability here means that a system can continue to work correctly even when something goes wrong. There's no doubt that TiDB is one of typical distributed system. This is the architecture of TiDB. In this diagram, there are four main components: the SQL layer TiDB, the distributed storage layer TiKV, placement driver PD, and our columns.TiFlash. These four components communicate with each other, so JBC crossing the network. So to test such a distributed system, we need to simulate kinds of faults. In this part, I will give you the reason of why Chaos Mesh. So some of you wonder why we chose Chaos Mesh to building a testing platform. The first reason is for simplicity. All the Chaos deployments are managed as custom resources, which means that we can use Kubernetes client to inject and rollback them. Here is a list of fault simulations which has been supported by Chaos Mesh. You can see that compared with other Chaos platforms, Chaos Mesh supports more comprehensive features. So it saves us lots of time on building diverse and completed testing environments. It's so cool. With the help of Chaos Mesh, we developed a platform for testing the stability and reliability of TiDB. That's a TiPocket. As we know, each ID is a set of properties of a database transaction intended to guarantee validate even in the event of error, power failures. So we developed some toolkits to build verification approaches to test databases. TiDB is a CP and HA system. Fault tolerant is another point, which is worth for us to take more efforts on it. For example, we should measure whether the ITO is met our expectation when diverse incidents occur. And to widen the testing coverage of TiDB, we designed some folders to create random inputs when testing. So TiPocket plays the role of a driver to combine these toolkits and the chaos injection functionality. This is the overall architecture of TiPocket. With the help of rich open source ecosystems, we can establish a testing platform from scratch easily. That's the reason why we embrace open source actively. From this architecture picture, you can see that there are 5 parts of components. At the far left is Argo workflows. Argo workflows is a workflow engine for orchestrating jobs on Kubernetes. We use it to schedule TiPocket cases for daily regression or release test. When a case is scheduled, it first enters the prepare stage where TiPocket invokes TiDB operator to create a TiDB cluster from scratch and set up a Loki client to fetch logs generated by the cluster. After that, TiPocket will put the case into the running stage where chaos mice shows his skills to break down the system in a managed way. Behind each round is a verification stage. We use some checkers to verify that whether the system is still healthy. So we built some tools for verification. GoCircleSmith is a fuzzing testing tool which generates randomly circle queries so it can be used to find panics with conditions and other bugs. GoCircleAnswer is our Go implementation of CircleAnswer, which is also a fast tool. It supports piecewise, no-rack TLP. If you are interested in how these approaches work, you can read these papers. Up to now, it has found 17 bugs on TiDB. To test the consistency, we designed some checkers. Bank case transforms account between those of shared table, and the pbank case checks bank accounts using a linearizability checker, Porcupine. Besides these 4 banks, we also use GoTBC to check the consistency of TiDB. The GoTBC implements TBCC and TBCH workloads defined on TBC. For TBCC, GoTBC runs the consistency checks after a round of benchmarking is finished. Although only the first 4 is required at the TBCC size, we usually check most all of these 12 conditions. These cases and verification methods are running with chaos injection. We designed several different kinds of chaos scenes. As your name applies, random kill, kill all, minor kill, etc. inject service long downtime, and a short kill takeaway, short kill PD leader inject short duration of service available. Partition 1 encapsulates the network chaos and isolates a single node from others each time. We also define 5 timescale chaos. Inject timescale from the smallest 100 milliseconds one up to the 5 seconds one. When TiPocket trigger chaos event, it writes a log to tag the beginning moment of chaos and its scene's name. It's useful for us to troubleshoot the system. So on TiPocket, we use Loki to connect logs and dump the TiDB cluster logs on local and build artifactor in Argo. Loki is like Prometheus, but for logs. We use this Go client to dump logs at regular intervals. You know, we use Argo to manage your cases. In this last part, I will show you how we schedule type of cases using the Argo workflows. For each case, we need to write a workflow template that defines the input parameters and the output artifactors. We use artifactors to pack TiDB cluster logs for analyzing after finding a problem. After writing the template, we should consider the way to trigger the template with specified parameters. Argo provides workflow and cron workflow to schedule. And we can override parameters on the workflow files. So we chose the cron workflow for regression testing. Argo provides a command, so submitting a new template and the workflow is very easy. In this case, we can use Argo template create to submit a template we defined just before, and use Argo cron create to submit a cron workflow. This is a screenshot. You can see there are running 3 cases here. Okay, thank you for listening.